Okay, in the other video, I already gave an example of how to solve for the current and the voltage drops and everything across these complex resistors for each one. So whether you watch that one first or watch it second, it doesn't really matter. I'm going to just go through a couple here to try to just talk about some like strategies, okay? Like how can we take these complex, especially this one, and we could just make them look a little more simple, or like where do you start, okay? So, and just to give you like an idea, this is one that we did. I don't even know if you could see this down at the bottom. Let me stand up. But like something like this is one that we did like last year. I got these offline. You could just draw any crazy thing and you'll always be able to figure out values and whatnot. Some students really like these because it's almost like a challenge. Like I remember growing up, we did these like logic puzzles like in elementary school, and I hated them. I can never get the actual answer. I kind of feel like these are the same things, but I could actually get the answers in these. So, so where do we start? Okay. First off, I'm not going to actually do any solving with numbers. Okay. So we just have R1, R2, 3, 4, 5, 6. First, we need to identify a little bit at least what's going on, right? Where's our series and where's our parallel? Series here, okay? And that's our simplest series. And then you can see that this and this are parallel. This, beep, this thing goes off all the time. Beep, I'm sorry. And this resistor are in parallel, okay? In the end, I think I said this on the other video, we're basically gonna have a situation where we just have like this line of resistors in series, okay? So where do we start with this one? Okay, very similar to the one I did the example for, but I always look for parallels because really we want to get rid of the parallels here and here. Okay, we really want to get rid of the parallels so we could get down to series. Okay, now if we take a look at this one right here, and you could call it anything you want. You know, I tend to call them like 4, 5 if those are the ones combining. So R4, 5 is equal to 1 over R4 plus 1 over R5. Okay? And that would get rid of this one. It would turn it into 1. So a lot of times I'll talk about equivalent resistances. And I always refer to like at the very end. If we take all these and make them equal 1 resistor. But really, you know, this would be the equivalent resistance for this little setup right here, okay? Now up here, what would we do? Well, in this case, we have a little situation here. We can't do the parallel until we get these together, okay? So the first thing would be R1, 2. It's R1 plus R2. Remember, the reason this looks different than this is because these are in series and this is in parallel. Okay. Now, what would we do with this R3? Okay. Now, a lot of times at this point, I would redo some drawings. And in the other example, I actually made this. I made extra drawings along the way just because I thought it was easier. Like, we could actually combine a couple situations and draw them in the next schematic. But in the other one, I think all I did was I basically put these together. R1, comma 2. This is still R3. See, and they would come down, and this would be like R4, 5. Okay? Now, if you want to, and they don't have to be pretty drawings, if you want to, you know, you could leave this the same as here and just do one at a time along the way. I think a lot of times for students that'd be easier, at least when you first start doing them. You know, as you get better at it, well, then you start to not do shortcuts, but you start to combine some steps together because you realize you can. This right here is parallel. So what are we going to call that? I called it in the other one R1, 2, 3. You could call whatever you want. Does not matter. So it'd be 1 over R12 plus 1 over R3. And I'll tell you this. If we were to give these some values, like let's say R1 was 10 ohms, R2 was 3 ohms, and whatnot, a lot of times I will actually label, like if this was 10 ohms, I'd label it R10. If this was 3 ohms, I'd label it R3. So that the little subscript would always just be the amount of ohms in that resistor. Okay? Sometimes that was easier for people. Other times, you know, they didn't like that. So you have to figure out what you like. All right? So here now we would have R1, 2, 3. All right? So after that, and we combine those, we would have a setup. Kind of running out of room here. It's going to be hard to see, I think. But I have my potential difference here, my voltage. It will come out to what I call R1, 2, 3. Come around to R4, 5. Hit up R6. And then it would go back, right? So here, combine those, and then we'd have this set up. And then lastly, they're all in series. So in the end, Req for the entire thing together. And truth is, a lot of times people will draw this one last, like this, and they'll just call it Req. Okay, but that's going to be R1, 2, 3, plus R4, 5, plus R6. And that would be it. Okay? And then following the example, then you'd work yourself back, figuring out the current and the voltage drops across each of the resistors. Right? So, show some of the logic that I do along the way. All right? Now, how about if you have something ridiculous? Right? I think we'd all agree those look ridiculous. Okay? So where do we begin? I told you I like to look for parallels. Okay? And let's just try to think about what's going on here, right? This comes out, goes here. And I need to do a better job of this. This is the positive end. This is the negative end. We should draw our currents going this way. I. Because that is the conventional way to do it. Even though the electrons move this way, the conventional way is to think about flow of positive charge, which doesn't really happen. But that way, if we do this, you watch videos, it would at least make sense, because most other people, when they do these, would have the conventional flow of the current. Okay. In the end, it actually doesn't matter how you look at it. But anyway, we have a couple parallel situations here, right? These are parallel. These are parallel. If you also notice, this whole side here is parallel to this whole side. All right? So if we can get these together, and then these together, you notice it would be in series now, here, into the 1, formed by all this junk, literally, right? Maybe, I don't know, how do you think of it? And then it'd come out the R8, and then we'd be back around, and we'd be in a series, okay? So I'm going to do 2 of these at once. I'm going to do this one, and I'm going to do this one. All right? And honestly, like I said in the other one, my suggestion would be that you draw multiple pictures along the way. I'm going to try to shortcut this a little bit and just combine some things, okay? So 1 over R3, I guess we could call it R2, 3, right? 2 and 3. Is 1 over R2 plus 1 over R3. Okay? And in this one, 1 over R5, 6 is 1 over R5 plus 1 over R6. Now, I've said this how many times, right? Make sure you do this math right. This is what parallel looks like when you're finding the equivalent resistance for this situation. Okay? So I'm going to draw the new picture. So down here, I want to make a quick point here too. You see how in this one I drew like multiple little short long lines? That's fine. depending on where you look and what you see, sometimes you'll just see one large one and one small one, plus minus. Other times you'll see like large, small, large, small, large, small, large, small. They could put as many as you want. It doesn't mean anything, right? So don't be confused by that. So first off, we come over here, R1, comes up, makes the split. This would still be R4, but then it moves into R5, 6. Okay? And on the bottom, right, so that'd be this whole top part right here. On the bottom, we would go to R2, 3. I'm going to keep saying R2, D2. Anyway. And then we go into R7 before they combine again. And that'd be R8, right? So these two combine. You see how this goes here, here, right? And so now we'd be doing, this is parallel and this is, I'm sorry, these are parallel to each other. But first off, we'd have to get these series together. Okay. And the way we do that is R4, 5, 6 is R4 plus R5, 6. And that's how we would get this whole one. Down here we would have R2, 3, was that a 7? Looks terrible. R2, 3, 7 just happens to be what the resistors were numbered as, because I kind of went in a weird order possibly. Is R2, 3, plus R7. You can't even read it, that's terrible. But it's R2, 3 plus R7. Okay. So we're going to make another drawing. I'm going to get another piece of paper here with all those things combined up together. I don't know if we can see that. I think we could see enough if I kind of do it like this. There we go. All right. So start out on the bottom. We have R1. Comes up. Makes the split. Now we have these two. This is still R8. This one up here, though, would now be called R4, 5, 6. And this one would be R2, 3, 7. Okay, see how we went from here to here. This one, this one. Now we have our parallel situation here. This is getting even like, the more resistors you have, that's why maybe it'd just be easier to call like RA or R whatever. I don't even know what I want to call this. 1 over R 2, 3, 4, 5, 6, 7. I don't know. You don't have to name it all that junk, but it's up to you. Sometimes it helps me realize what resistors are just in that whole setup. Okay, R4, 5, 6, R2, 3, 7, and we get a resistor for that. I'm gonna kind of stop at this point, but our last drawing would be R1, whatever we called this thing up here, R2, 3, 4, 5, 6, 7, I guess, and then come around here to R8. Okay. And so lastly, the big REQ would just be this plus this plus this, right? Add them all up. And then we'd have to make that trek backwards. Okay? Now sometimes when you do these problems, they won't even ask for like, what is the current and voltage drop for each of these resistors? It might just say, hey, what is the current through R2? So as you work your way down, I call it work your way down. You make your schematics look, your circuits look a little more simplified and smaller. You might not have to go all the way back before we get to somewhere where there's R2. okay, or R1 or whatever. All right, so yeah, I think sometimes students have fun with these a little bit because it is sort of like kind of like a little bit of a challenge, especially if you're not like, going to be graded very harshly on right or wrong if you have some huge one like this. Okay, but yep, it's just kind of where I would start for a couple of these.